For our last binomial in this series of binomials that we are factoring, I chose one that's a little different looking. We're used to seeing the variable in the first term and maybe a constant in the second term. But here, the constant's in the first term and the variable in the second term. I don't change my approach to factoring just because I have that. I look to see, is there a common factor I can factor out? Answer, no. This is a binomial. It has to fit that special pattern of difference of squares. Is it a difference? Yes, there's a subtraction, so it's a difference. I still come over to my squares skeleton and see if I can create my squares skeleton for this binomial. What could I square that makes 36? Well, that would be 6, wouldn't it? What can I square that makes x squared? That would be x, wouldn't it? So this is the difference of two squares. It's 6 squared minus x squared. So it does factor. Factors into two binomials, one with addition, one with subtraction. What goes into the first positions? It's what I have in the first position of my squares skeleton. What goes into the second positions of the binomials? It's what I have in the second position of my squares skeleton. So there's the factorization of that binomial. It's kind of a strange looking binomial with the variable in the second term, constant in the first term, but I applied my same procedure for factoring and found the correct factorization. If we multiplied these two binomials with FOIL, it would create that binomial. The f of FOIL would be 6 times 6, which is 36. The O of FOIL would be 6 times minus x, which is minus 6x. The I of FOIL would be plus x times 6, which is plus 6x. And the L of FOIL would be plus x times minus x, which is minus x squared. Those terms combine to 0, giving us exactly the binomial we started with. So that is the correct factorization of that binomial. A little different looking, but still the same approach to factoring.